Mr. Ryan, are you right? Yeah?
Yeah.
Okay. In the early days, I think probably day 40 or 50, we talk about the square root, right? Square root. Okay. Square root of 9, what does it equal?
3.
Not quite.
-3.
Well done. So it actually has two roots. One
We
is
know!
plus 3. The other one is, yeah? Okay? Because
know.
both this square equals the 9, right?
No.
You learned this at school, right? But do you know square root of the -1?
No.
Okay, so it actually
One.
equals I. I is imaginary, stands for imaginary. So we say I square equals.
Oh yeah, that was in the
minus-
TED video.
TED, yeah, okay, but this is not a topic today, okay? So today we're given a non-negative integer, okay?
So
And-
this
and-
the square root of -2 is I.
No, square root of -2, right? This is equals to square
Infinite.
root of the 2i. Right? Because this is equals to 1 times 2, right? And then these 2 can be moved outside, and this thing
But
equals this.
That but then the square root of -9 is 3i.
Well done, yeah, got it. Okay, so if you're
And the
interested, we
square
can
root-
talk
and the
about more.
square
This is
root- and the
mathematics.
square root of 3 is -3 is 3i. Square root of 3 -3.
Yeah, square root -3 is 3, square root of 3i. Okay, I is basically the imaginary.
The square root of -9 and -3 are both the same.
No,
But you said
no,
that
no. He's saying that -9 is 3i and -3 is 3 squared I.
Okay, so given integer
So why
n,
is the square? Why
Non-negative.
the square root of -2 not 2 squared I?
It is 2 squared I.
That doesn't say that.
No, look what's on the board.
It's a 2.
square root of 2i. Okay, so let's move on. Okay, we given the integer n bigger or equal than 0, non-negative, and we want to find the nearest integer that squares to it. For example,
What do you mean squared to it?
so integer part for the square root, integer part near rounding down. For example, square root of 9, this should return 3. Okay, we abandon. We don't consider the negative. But how about square root of 10? You should return the 3 as well, okay? Because it's 3 point something, and then we round it down to 3. Yeah? Does it make sense? Square root of the, if we n given 101, what's the answer we should return? 10, yeah, okay, you get it, right? Okay, square root of 2, what should we return?
1.
Well done, you got it. Okay, so how do we solve it using computer programs? Right? How do we solve it using computer programs?
You
Why the
square.
square root?
You
No, okay, yeah. You can't use any built-in square root. You know, of course.
No, you could square root and then round it.
That's right. That because how do you square root of it? You can use that. If this is n, you can use this **0.5, right? This is in Python basically mean this. Or you can use the master power n 0.5. Basically, square root of anything. This is basically the same as n to the half, right? It's the same thing, right? Square root of n is n to the power of half. Okay?
I know.
Okay. So, but we can't use this. Okay.
Why?
Otherwise, it's meaningless. Okay.
Yeah, you could just like.
How do we find this integer n? Come on, it's
Okay,
very
just
simple.
stop talking.
Yeah. Okay. Then.
So, you have a list of all of the square numbers, and then you find, you get your number, and then find the closest one.
Well done. That's an excellent idea. Actually, I didn't think of that. But that's very
that's a-
creative.
How's that creative? That's
Because
like
because this is kind of new to me because I never thought about doing that. But I believe it can be done. Okay, so you're saying that 1 and then 4, 9, 16, 25. These are the square numbers, right? And then you're trying to find, for example, 10. Okay, so how does this have 10? So where?
no, 3.
So you find which one, right? But how do you know which one is it? You find the distance.
The one that's closer to the
I guess.
one.
But how about if they're equal distance?
Then round up. We round up. We're in
Then
UK.
tough luck.
Tough
We
luck.
go up. We round up. We're in UK.
Actually, if it's closer, yeah, of course. Actually, because we return the nearest integer that's no bigger than the one, so it's always to the left side, right? You always to the left side, so you always find to the left, right? This is okay. Let's try another example like 20. So which one? 4, right? Yeah, because you look for the left. Okay, that will work, right?
I
That will
always
work.
left.
Because we want to find the integer, the square root, which is, smaller, right? Smaller, because look, square root of n, you need to
What
give
do
me
you
the
mean
integer
smaller?
n. Sorry?
What do you mean? Just smaller.
So we want to return the integer, which, if the integer is x, the x squared should be less or equal than this given number n, okay? So it's a less or square. We want to return the largest integer. The square of it is less than or equal than the given number. So it's, in other words, it's rounding down. Okay, that's an excellent idea. In order to do this, we need to generate. But how do you know generate how many square numbers?
Well, so you get a number,
Yeah.
and then
So how many numbers you need to generate, to look it up? Suppose this is the table, and then we need to look it up, right?
yeah,
But there are unlimited number of square numbers. So how many do you want to generate?
depends on how big of a number.
Okay, so if this is 10, how many numbers you want to generate?
11.
Oh, excellent. Actually, yeah, it will work because why 11 is okay.
What was the question?
Because
What was the question?
Because you don't.
What's the question?
How many numbers you want to generate in order for this approach to work?
Because you may need to look up a number afterwards.
That's right, yeah. Because I think 11 is more than enough, right? Because because what? Because this n square is obviously bigger or equal than n, right? Yeah. So you're just saying, okay, if this is n, I want to generate n plus 1, but it's actually more than enough. Okay, that will work. Okay, so this is not the idea I would think about. How about BruteForce? BruteForce is the first idea, right? So we can BruteForce, right? We can try is 1 square bigger than n, 2 square bigger than n, 3 square bigger than n, 4 square bigger than n. If it's equal, then we return it. If it's not, then if it's not, then we check if it's bigger. If it's bigger, then we return the previous number. Am I right? But do you understand? Okay, so let me quickly write the code. This BruteForce should be very simple to implement rather than this, because this is a very neat idea, but in order to implement it, it might be taking more code to write. Okay, so
Bro, I thought you were senior.
yeah, I'm senior.
But you should know how to do it.
Yeah, okay. I will ask ChatGPT. Please don't.
Bro, you don't need to have to be senior.
Okay, we can talk about this next lesson, okay? So if, because n is bigger than 0, okay, so we need to assert, we need to check n is bigger or equal than 0. And if this n is smaller than 2, then we return n, right? Okay? Because if it's smaller than 2, then if it can only be 0 and 1. And then it should be, if it's 0, then we return 0. If it's 1, then we return 1. Simple, okay? And then otherwise, we just go from the first number to which number, Okay, so one number, we're BruteForcing. So what's the biggest number we check? Which number square is bigger than n?
N plus 1 squared.
N plus. So if n is 10, what number are we checking? We're checking 1 square, 2 square, 3 square, 4 square, 5 square. One stupid way, we're checking up to 10, right?
Yeah.
Okay, but do we need to check up to 10?
You need to.
Probably, So
10 squared plus 1.
10 squared plus 1. No, what number? So what number square is 10? So this number. So we can
10
check
squared. EDP, I'm feeling. 10 squared. EDP,
square. 10. You mean this?
Yeah.
Yeah, but the thing is that we are checking. We don't know, right?
Yeah, but how are you supposed to figure out that?
Yeah, so let's BruteForce. We try 1. square, 2 square, 3 square,
Yeah, but
and
10.
till which?
Yeah, but 10 squared isn't an integer, so you'll never find it.
So we are BruteForcing. So basically we
No,
check
but that's
number
not my
1,
point.
2,
That's not-
3,
Yeah,
4.
yeah, I know what you're doing.
Yeah, but which number?
I know what you're doing, but 10 squared isn't an integer.
I know.
Yeah, but you're saying what field were blank, but how are you supposed to know that? Like 3.
We don't know. That's why we keep
Then
trying.
why did you ask me that?
But at least we can check up to half. We can check up to half, which is 5.
Yeah, but
Because 5 square is bigger than 10.
yeah, but that's not a question you asked.
Okay.
You said that like what is something squared equals 10.
I see. Okay. My bad. Okay, so my.
You don't see that you've written that.
I see. Okay, but do you understand now? Yeah. The n we can check up to n divided by 2, but that's a special case. You know, if it's n equals 2, right? Obviously you can't check up to 1, right? Because 1 square is not bigger than 2. If it's 3, we check up to 1.5, right? Still. So in order for this to work, n needs to be bigger than or equal than 4. Okay? So if n is bigger or equal than 4, we can check up to half of it. If I times I is n, great, we have this number, then return I, right? Then if I times I is bigger than n, then we should return the previous number, right? I minus 1. But this is half, then we start with 1. For half of it, we need to,
Wait,
yeah,
do the numbers need to be integers?
plus 2. Integer, yes, has to be integer. We are finding the nearest integer, the largest integer. We want to return a,
like, does n have to be integer?
yes.
Uh,
Okay. So we are finding integer. Like previously, we talked about finding the solution, which is the real number, right? It could be containing the fraction, right? And that could be different. Because if you want to find out square root of 10, we talk about different approach. How do we estimate the square root of 10? Is what? How do we?
3.14159.
No. Okay, very good. 3 is a good number. Yeah, because it's bigger than square root of it's bigger than square root of 9, right? Yeah, this is 3, right? So it's a 3 point something. Let's say 3 point something. This bit is x equals 10, right? Okay? And then how do we estimate? So this one, right? A plus b square, right? We talk about that. A plus b square equals a square plus b square plus 2ab, right? This equals 9 plus x square plus 2 times 3 times x is 6x equals 10. Because x is a fraction number, decimal. So it times itself is small. So for now, because it's so small, we just ignore that. Can we? Yeah? And then
No.
we are estimating, okay? 6x plus 9 equals 10. So 6x equals 1. X equals 1 divided by 6. Okay? So now we got an estimation. X equals that. So the square root of 10 equals 3 plus 1 over 6. Okay? This is what? What's this number? 1 divided by 6, right? And what's the 1 divided by 6?
0.666666666.
No.
Okay, let me do this.
It's 0.15. No. 0.16.
16.
Yeah.
Okay, 16. Okay, 0.1666. Okay, now we have this 3.16 plus x, and we can repeat this process until we get a good estimation. Okay? Yeah. Okay, this is BruteForce. Okay, the tricky part is this bit. Okay, we have to put more integer because of this, right? Because if n is smaller than 4, then half of it will not cover the root. Okay, this is BruteForce. Actually, you know how do we talk about finding the square root using the what search? Fill the blank.
BruteForce.
This is BruteForce. We want to look. This is monotonal. Come on, please. Please, come on, too noisy. Okay. Here. One more thing. Okay. Look. 1 equals x equals This is x squared, right? This is x, this is y. Y equals x squared. This bit, for the positive bit, is this monotonal increasing? Yes? Yeah? If it's monotonal increasing, we can use the binary search, right? Remember, we talk about binary search, the narrow down, right? Yeah? Does it make sense? Yeah? Everyone?
Yeah.
So what's the time complexity for this? Okay, n is, yeah, because we search up to half of n is still on. O, n divided by 2 equals, right, equals on, yeah, because we drop the constant. So basically, the idea of BruteForce is we check the integer 1, and we check integer 2, we check integer 3, we check integer 4, right? Yeah? We can also check, can we check from the biggest to the smallest? Can we? Look, Eric, Ryan. We are checking from 1 to 2, 3, 4 up to half, right? Can we check the opposite? Can we? Can we check the root from n half divided by 2 and then minus 1 up to, for example, square root of 10. Can we check from like 5, 4, 3, 2, 1, right?
Yeah.
We can, right? But it's a bit tricky to deal with the. We need to check if the previous number. We need to check if current number is bigger and then previous number is smaller. Then we find the answer. Okay. That's it for today. Bye bye. Bye bye.